Hello everyone and welcome back to Ocean Cadence, a place where we explore the science and systems behind ships and the maritime world. Today in this video, we'll be diving into one of the most commonly onboard implemented and utilized motor starting and control systems, that is one of the most common systems found on ships for the starting and control of common used and applicable motors, which is called the direct online starter, or as we can simply regard it as the DOL starter. As a part of build up towards understanding the DOL starter, we'll also put our efforts into understanding the basics of what a starter is, why we need a starter for running a motor, and how the DOL starter circuit works. And we'll also look into its applications and limitations in the marine environment. So let us start. To understand from the very basics, a starter in a nutshell is an electrical device that is predominantly used to start, stop and act as a protective aid for an electric motor. In the marine systems, that is onboard ships and the electrical systems onboard ships, we use starters to safely bring motors, for example the motors that drive seawater pumps and the fuel oil transfer pumps and even the heavier pumps etc. into operation. Why do we utilize these starters? It is because when a motor starts, it draws a large amount of inrush current, which can be typically 5 to 7 times higher than its rated full load current. This sudden surge can cause voltage drops in the distribution system, affecting our other machinery and the other available equipment on board. A starter typically limits this high starting current and provides control and protection during the starting of the motor operation and thereafter. So, to further understand why these starters are so important on board for the starting and operation of motors, imagine that when a motor is directly connected to the supply and started instantaneously, it will try to reach the full speed instantaneously. That is the main running RPM or the final running RPM. It would try to achieve that RPM instantly. But during the starting period, the rotor is stationary and there is no back EMF. So the motor will draw a very high electrical current. Because there is no back EMF generated initially to oppose the applied voltage, resulting in low effective impedance and hence a very high starting current to be drawn. This is also further coupled by the fact that in induction motors there is higher slip and low inductive reactance at the starting of the motor. What this will do is that it will damage the windings of the motor due to excessive heating as a virtue of the extraordinarily large starting current drawn. It will also trip the circuit breakers and it will also cause voltage dips in the ship's electrical network. This can be very dangerous, especially for critical elements or essential machinery like the steering gear or when the compressors are running. This is the primary reason why we use starters to ensure smooth and safe starting and the stopping operations of a motor. As said before, one such common starter is the direct online starter that we are discussing here in the topic, or the DOL starter. So now let us have a look at how the DOL starter works. A DOL starter connects the motor directly to the supply voltage and hence that is where it draws its name, that is direct online. Now let us break down the circuit. First of all, a three-phase supply in the form of indications of RYB is fed through fuses or circuit breakers, which protect against short circuits. The supply then passes through a contactor, which is an electromagnetical switch operated by a magnetizing coil. We also have an overload protection, which is typically a thermal overload relay which trips the circuit if the motor draws excessive current for too long. Thereafter, finally, the three-phase supply and the current finally finds its way into the three-phase induction motor. Now, here's how the control circuit operates. When the start button is pressed, the current energizes the magnetizing coil of the contactor. This closes the main contacts of the contactor connecting the motor directly to the three-phase supply. At the same time, an auxiliary contact known as the holding contact keeps the coil energized even after the start button is released. If the stop button, which is a normally closed contact, is pressed, it breaks the circuit, de-energizing the coil and disconnecting the motor from the supply. This, in a nutshell, is the basic operation of a DOL starter. Since the DOL starter connects the motor directly to the line voltage, the starting voltage across the motor terminals is therefore 100% of the supply voltage. This means that the motor experiences a full starting torque, which is roughly amounting to 2 to 2.5 times the rated torque. But this also means that the starting current can shoot up to 6 to 8 times of the rated current. Now, why we are emphasizing on this point is because we initially said that the purpose of the starter is to make sure that initially when the motor is starting, it draws relatively lower load, that is lower supply of electrical current. But as we can understand that the DOL starter is not very suitable for this purpose. That is why DOL starters are often used on board only for small motors. By small motors, we mean motors that run small machinery like relatively smaller pumps, fans or smaller compressors, and they have restricted usage in terms of higher kilowatt or higher load machinery. Under most distributions, you will find that this type of starter is limited between 10 to 25 kilowatt of load equipments. So, where can we use it then on board a ship in terms of practical implementation? We can use it for relatively smaller seawater pumps, the fuel transfer pumps like for example the DO transfer pump etc., which do not draw very high starting current and have relatively lower load during operations as well, or for certain standby units which have relatively lesser surges or relatively lesser load in terms of operation. So essentially the protection provided by the elements involved within the construction of the starter, so for example the overload relay etc., is the primary benefit providers that exist, and that is why the DOL starter is often regarded as one of the simplest and most robust ways of starting a small three-phase induction motor on board ships, since it provides direct connection, overload protection and very easy control on such motors, and therefore it also incurs a very lesser cost and very less maintenance routines also, which are very simple in nature, so easily implementable. It also means that as we will move on later in our other videos, you will understand that the larger motors which are used on board, for example the heavier or the main seawater pumps, the main air compressors and the winches or any other, for example the ballast pumps, they will use star delta starters or auto transformer starters instead, which are the other varieties or the variations in the electrical starters that are used for starting and operation of motors. I hope that you have found this explanation helpful along with the diagram and the animation. So please don't forget to like, share and subscribe to our channel Ocean Cadence and help us grow as the one-point channel for all marine engineering insights explained clearly and practically to you. Also, please feel free to drop into the comment section and let us know your questions and your suggestions for other important videos that you would like to see, and do not forget to visit our other available videos as well. Thank you.